Well, good morning, class. Welcome to Pre-Calculus. We're going to learn about inequalities. We're using polynomials and rational functions. So there's a lot of words on the top. I'm going to straight up ignore those, because if you want to read that in your own time, you can read that in your own time. I'm going to kind of go through and give you my own step-by-step way to do this stuff. So let's just go ahead and do number one. All right, hey, I'm going to give you some steps along the way, though. So you can copy these down. So steps. Step one is to get, that's my verb I'm going to use get all x's on one side and into one fraction. That's if possible. This is not a fraction one, so you can ignore that second part. So step one. All right, how's step one looking? Good. Good job. We did step one. Woo! Step two. Factor. All right, let's go ahead and do step two. Let's go ahead and factor this. How does this factor? X minus 3, x plus 2. Step 3 is to find roots and vertical asymptotes. Well, this is a polynomial, so are there any vertical asymptotes? No, I'm good. So we're good on that one. So let's go ahead and find our roots. So what are our roots here? 3 and negative 2. We're going to make a sign chart. So that is going to be step 4, is make a sign chart, which is this right here. Okay?
A line graph? A numbered line.
Sure, but this is going to have a lot more things on it. Like, there'll be signs.
Okay.
And it is a chart. I call it a sign chart. Okay, so now we need to put two numbers on this sign chart. Please put them in the correct order. So what comes first? What comes furthest left? Now, I'm going to put an open circle that represents negative 2. The reason is because this is a does not equal. What's going to end up happening here, I'm going to figure out what's going on here with signs, if it's a positive or a negative, and I'm going to shade whatever statement is true. This is a does not equal, so I have open circles. Okay? And then at 3, I'm also going to have an open circle. This should not be news to you. Okay? Now we're going to check each interval. I'll just say that, and I'll kind of tell you what I mean by that. So in each interval, we have to pick a number. Okay, so we have an interval that's left of negative 2, we have an interval that's in between negative 2 and 3, and an interval that is bigger than 3. Okay, we have to pick out a number that's in an interval, and we're going to test it to see if we're going to get a positive value or a negative value. Because everything left of negative 2 is either all positive or all negative. Everything in between is either all positive, all negative. Everything after is either all positive or all negative. So what's the number that we can check out here? Negative 3. So I'll write that like a little eensy-weensy tiny negative 3. That just tells me that I know what I'm picking. Always go back to the factored form. That's the easiest way. So what's negative 3 minus 3? I only care about signs. Don't tell me what the number is. It's negative.
Oh, I thought you said you didn't care about signs.
That's the only thing I care about. It's a sign chart. And negative 3 plus 2. Negative. What's negative times negative? And then I always put that up top and I circle it. That means that everything left of negative 2 is positive. What's the number to pick between negative 2 and 3? You get a chance to pick 0, you got to pick it. So let's pick 0. If I pick a 0, 0 minus 3 is negative. 0 plus 2 is positive. What's a negative times a positive? It's a negative. And then What's the number that's after 3? So I'll pick a 4. You don't need to write these numbers down. I'm just doing it for the sake of notes so you understand that I'm not just picking random things. So 4 minus 1, or sorry, minus 1. 4 minus 3 is positive. 4 plus 2 is. So this is going to be. So we did that. Check each interval. We're going to shade the true statement. Or the true, I'll say the true interval. And then we're going to express answer. Okay? These are our steps here. So, I'm looking for numbers that are smaller than 0. You see how 0 is bigger than these things? What sign is that? Is that positive or negative? Numbers that are smaller than 0 are negative, so I'm going to shade the negative part. This is my true interval, so I have to express my answer with what I just shaded. So what is my interval? It's -2 to 3. They are parentheses because they are open. Okay? And that's my final answer.
What would happen if it was the one on the left, where numbers were smaller?
Yeah, if it was the outer guys, it would be -infinity to -2,
Okay.
and then from 3 to infinity. And that's really about it. Okay, go through all of these steps. I know there's 7 steps. Some steps are already done for us, nice and easy. Others you gotta do a little work for them. So let's go ahead and do number 2. You want to try 2 on your own?
That's kind of really big.
It's grouping. You should all know how to group. So do step 1, get all the x's on one side, then factor, then find the roots. There's no vertical asymptote. Make a sign chart, check each interval, shade the true interval. Express your answer.
Why did you use the 48 for the other side? But 48 isn't it? Do I have to move the...
Okay, move all x's and numbers.
Okay. That makes sense.
Good call. And I'll do it along with you. I'll give it another minute. Please at least match up with me.
What if it's 0? Like, would that be a positive sign, or would that be a negative?
That means you plugged in the wrong number. Because we are...
Plug in -4 to x, and it has to be 4.
Right, and you shouldn't plug in -4, because we already know it's a 0. We want to plug in numbers that are not zeros.
Oh, crap. That makes sense. I did that wrong. What did you?
Alright, and I'll kind of do this. I'm going to put in negative 5 and see what I get.
Oh, I was like, did I really say that? Yeah, I was thinking for a second.
Any questions where I'm at right now? I hear lots of murmuring.
Wait, how do you know if it's true?
Okay, so we're looking for numbers
Oh.
that are bigger than 0. Positive numbers are bigger than 0.
Explain to me why the third one isn't a negative sign. Oh, it is a negative sign. I was like,
We're having a great day today.
yeah, I know. I just want
What'd you get there from Dunkin' Donuts? Is that like a tea or
coffee
it's a coffee?
with literally no cream and sugar because
It's a black coffee?
basically, not really.
Wait a minute. It's got no cream and sugar in it.
I said with literally no cream and sugar. Like,
So, what does that mean? Literally, no means none.
as in, they didn't put enough.
There's practically no. That's practically, not literally.
Literally no.
Where's there Dunkin' Donuts around here?
It's, I went to one by the shop.
What's the shops?
The shop's a legacy.
What's that?
You know the shop, legacy?
I don't live here.
Where do you live?
Oh.
Where do you live? Not like in a weird way, but like, do you not live in Bristol?
No, I live in Coppell.
You drive from Coppell?
It's like 25 minutes.
That is a long drive. There are teachers who drive like an hour.
I used to drive 40 minutes to work like for the past 5 years of my life, and I finally worked somewhere that's closer.
What time do you leave your house to like get here early?
Well, I mean, like I have kids that I drop off to preschool, so I leave my house about 7:20, drop my kids off at preschool, and then I come here.
You know what time I wake up? 8:40.
Yeah, not good.
Yeah.
Wait, so you had time to wake up at 8:40 and grab a Dunkin'?
No, not today. I woke up early because my friends live over and she's like, let's cook coffee. And then I just
Wait, you have sleepovers on school nights?
Yeah.
Oh my god. Alright, hey, let's get back to the problem here. Okay. Any questions with where I'm at right now? Any questions? None? So my answer will be -4 to 3/2. Union sign 4 to infinity.
Wait, there's no bracket.
No brackets because none of it equals. 3/2, I just solved 2x minus 3 equals 0. Real quickly. Okay, hey, real quick. Whenever you do sign analysis for polynomials, I always think they're super easy. I went through the long way with you. Polynomials are super easy. Don't you already know how to graph these? Yes. So this is an odd powered, and it's positive. So what's negative positive? I already could have did that right off the bat without testing anything. And are any of these bounces? They're all cuts. So they're going to change signs every single time. Okay. All right. So it's an after that, all that Dunkin', go for it. It's an odd positive, so the signs are going to be down and up. So I know the outer two, and I know alternate signs because these are all cuts or crosses, whatever you want to call them. So they change signs every single time. If you get a bounce, it won't change. Okay, so you don't need to test everything, but it's very helpful, especially for the first couple of times ever doing it. Got it? I'm all about shortcuts, so I'm here to kind of tell you now, hey, there's a shortcut. What's that? A twist actually goes through it, so a twist isn't going to affect it. It's the even powers that will affect it. Alright, so these are just some like weird problems. These are called unusual solution sets. You just got to stay true to yourself in your math world. And a lot of times people get solutions from these. They're like, "Oh my God, what do I do?" And I'm like, "Just use your brain." They're confused because they don't get a nice, pretty little answer. So, like on number 3, does number 3 factor? No. So all the x's on one side, it does not factor. Okay. So, are there zeros? There could be. How could we find that out? The quadratic formula. So let's go ahead and do the quadratic formula. So it's going to be -2 plus or minus, this is x equals -2 plus or minus square root of 2 squared minus 4 times 1 times 4 all over 2. You're going to get -12 all over 2. Okay, so are there any zeros? I'm talking about in the real world. We're pretty much, if we see imaginary stuff, that's a no-no because we're out of that unit. So there are no zeros. Everything is going on either above the x-axis or below. So when I make my sign chart, there's nothing put on there. There's nothing. So pick any point you want because there are no zeros. What's an easy point to pick? 0. What happens when I plug in a 0? I get a positive. No, when I plug in a 0, I get 0 squared plus 2 times 0 plus 4, which is a positive number. Okay? What am I looking for? Positive numbers. So what's my answer? All real numbers. Negative to infinity. What if this was flipped the other way? There'd be no solution. Sure, if it's all real numbers, you want to write a little r, be my guest. Make sure it's a bold R. It's not just a regular R.
Oh yeah, with the 2.
Yeah. Okay, since there's no zeros, you can plug in any value you want. So I plugged in a 0, and then so I'm going to get 4, which is positive. So everything's positive. It's impossible for it to ever be negative because there's no zeros. There's no chance it does not cross or anything like that. This is all real numbers. Okay? Let's go ahead and do number 4 real quick. Does this one factor? This one does. This one factors how? So it's x plus 1 squared. So this one's going to bounce where? At -1. And this is a solid or an open?
Solid.
It's a solid. At -1. And now go ahead and plug in numbers that are less than -1, which would be -2. And then you're going to get -2 plus 1, which is squared. So it's positive. So this is all positive. And then plug in a 0. And what do you get for when you plug in a 0? You get a positive, so you get positive.
So it's the whole number line.
Well, what am I looking for?
So it's none of them.
It's almost none of them. It actually is -1. That's my only answer. Because this interval is not true, this interval is not true, but it actually does equal 0 because of this little special line right here. It actually does equal 0 at one point. Yeah. No, when it bounces, they're not supposed to change.
See, like it'll go.
When it cuts or it twists, wiggles, whatever you people call it, flatten is better. Okay. Okay. Hey, I'm not going to do these. I'm just going to really quickly talk about these. So this one, if you do the quadratic formula, you're also going to get a negative value. Just giving you a heads up on that one. So this one will be all positive numbers, but can that happen? No. So this will be one where it's all positive. Just trust me on this. And this one would be no solution because there's no true statement that can be made from this one. Okay? And then this one, let's do this one because this one we got to be careful about. So this one factors as x minus 2, x minus 2. So this is going to give me a 2. And this is an open circle. And this will always be positive. Do you agree? So this will be positive over here because no matter what you square it, you're going to get positive. So it's positive, positive. So the answer is almost everything. It's everything except for 2. So there's two ways to write that. You can actually write it the way they did in your homework. So all real numbers such that x cannot equal 2. Or you can just go negative infinity to 2 and then 2 to infinity.
Why do you have to do U? Because there's 2.
Yeah, it means you're uniting the two sets. So those are just weird, unique things that might happen, but you can just figure it out by using your brain. So that's the polynomial stuff. Let's get to the rational stuff. Okay? This we're gonna do the exact same thing. Same steps that I originally wrote out. Same steps, except now we're gonna talk about fractions and vertical asymptotes. That's the only difference here. Okay. So let's go ahead and find the solution set. So, is everything on one side? Yes. Is everything factored? Yes. Let's find my zeros and my vertical asymptotes. What are my zeros? Negative 3 is my 0. And what's 2 going to give me? My vertical asymptote. This is my vertical asymptote. Vertical asymptotes are always open circles, no matter what. Vertical asymptotes are always open circles. I'm going to keep saying that over and over again because I know you're going to get this wrong at some point. Vertical asymptotes are always open circles. Vertical asymptotes are always open circles. If you're watching a YouTube video, it is not freezing, it is not glitching. Vertical asymptotes are always open circles! Can never be closed. I say that like, that's so funny, he keeps repeating it. You can get your test back in like a week and a half. Oh. I should have listened to him. That wasn't that funny. So, are we ready to make my number line now? Okay, so what are the 2 points I care about? Negative 3, which is open or closed? Why? Because this doesn't have a line underneath it. And what's my other value? And why is that one open? Good. I repeat this stuff because I've been teaching this for so many years. I know where everyone makes their mistakes. And then when they make their mistakes, I used to just bang my head on the wall. Like, I just told them 1,000 times. And then at this point, I'm just like, yeah, they shouldn't be here. They don't listen. Did I say that on video? Yeah. That was a joke. Okay, so let's plug in a value that's less than... By the way, this is not a polynomial, so my tricks don't really work here. I mean, they kind of sort of could work here, but they really don't. So let's go through and plug in these values. So what's the value that's less than negative 3? Negative 4. When you plug in a negative 4, what happens on top? You get negative divided by negative, which gives me a positive. We're gonna be doing some, by the way, where we're gonna get like a bunch of these, like negatives and positives, negatives and positives. If you have an even amount of negatives, no matter what, it's gonna be positive. If you have an odd amount of negatives, it's gonna be negative. Okay, so let's pick a value between negative 3 and 2. 0. And I said pick 0. What do I get on top? Positive. Over. Negative. This is negative, and then pick a number that's bigger than 2. Pick a 3, and we're gonna get over, which is, so what statement is true? I want numbers that are bigger than 0. So the positives are true. So my answer is isn't this so fun? Alright. I mean, there's so many different types of examples. I'm not going to go over all of them. I'll do some of them though. So this is a good one to do. I'll do like 2 more. Okay. No. But they're all repetitive. They all do the same idea. This is, if we can do this one, we have the main idea, and then I'll have you try one alone. If we're all happy, then we'll be done. Okay. So.
If it's like the same idea, should we do like one from each?
Are you questioning? By the way, you don't have homework. Are you questioning the classwork?
I'm questioning that in general.
Okay.
Do you know when like they give you worksheets and it's like multiple of the exact same questions with different numbers?
Yeah.
If I can do it the first 2 times, can I do it the next 5?
Sometimes you need repetition to make sure that you're doing it correctly because that's how the brain works. It's muscle memory. Okay, so let's go through this. What's my first step? What was my first step initially? Get all x of the numbers on one side and into one fraction. Is that true right now? We're going to do this 3. Subtract it. So 2x minus 7 over x minus 5 minus 3 is greater than or equal to 0. Is this into one fraction? How do I make this into one fraction? Get common denominators. So I need to multiply the 3 by x minus 5 over. So I'm going to do x minus 5 on top, and on bottom there's an imaginary 1, correct? Multiply that one by x minus 5. So when I do that, I'm going to get 2x minus 7 all over x minus 5 minus. Well, I'm doing 2 separate fractions. I know what you're saying, but plus. We'll distribute it in this next step. I usually question you.
I question myself.
So what's 2 minus 3x? Negative 1x. Can I just put a negative x? What's negative 7 minus negative 15? That's a plus 8. All over. Now this is a hot take here. This is my opinion. I don't like having negatives in front of my highest power stuff. I don't. So I'm going to divide it into negative 1 for fun. So it becomes x minus 8 on top. Bottom stays the same. I didn't touch the bottom. Alright, that's my hot take. I don't know. Isn't that what you kids are saying these days?
No. No one's ever said that.
No one is. So I'm ahead of the curve. You're all going to be saying it in years to come. And where do I hear it? My kids will be saying it when they're older. It's a hot take. I don't know.
I've never heard that.
I heard it from somebody. Okay, good. Don't tell me you heard it from like an old person.
No.
Good.
There's like a YouTube channel that does like cool news stories and they call them hot.
No way. So I'm cool.
Yeah.
Someone just said no. Oh my god. All right, let's go ahead and make my number. So what are my zeros? 8. What's my vertical asymptote? This is where you're gonna make the boo-boo. Well, not this time, because I'm here to help you out. So what's the first number that goes on here? 5. Is that open or closed? Why is it open? Very good. And then 8 is open or closed? Oh. So now be careful. This negative, that's got to go through the entire time. So when I do this. So on top, what number you want to plug in first off? That's left of a 0. We're going to go left of 5 first. I usually work from left to right. So plugging in a 0, on top, I'm going to still have that negative when I plug in that 0, that's going to be a negative all over a negative. So that negative is going to stick through here no matter what, because that negative is not going to go away. So this is going to give me a negative. The next number we're going to plug in is a 6. So, 6 or 7 doesn't really matter. So you're going to get a negative over, which is a negative times negative is positive. That's a good joke. All right, and then what's the number that's after? After 8. Oh, there goes my neatness. 9. So you plug in a 9, you're going to get negative. Yeah, we got to start the video over again. Negative, positive all over. Positive, which is? Which statement is true? I'm looking for numbers that are less than 0. So the outer ones, so the negatives are true. So what's the answer written as?
Negative infinity 5 bracket 8 union. What?
Okay, level of difficulty. A 2 out of?
10.
Sure. Level of annoyance?
12.
Pretty high. Not a 12. Pretty high, right? It's not difficult. It's just, it's time consuming. It's tedious. So let's go to the back. There's 4 of them.
Can I do it on the board?
Yeah, let's not make that a thing.
You don't like that? I love doing stuff on
Well, then the video can't see it.
Did I ask them? It's because I like writing on the board.
Okay, so look at all these problems real quick. I mean, there's nothing here that's any different than what we just did. Nothing really that different. Like number 9's already set up for us nicely to do what we just did. It's an easier version of it. Same thing with 10. 10's already set up. This one just happens to have 2 fractions, and so does this one down here. So let's do 11 or 12. Your call.
11.
Try 11? Why don't you try 11 on your own, see how you do, and we'll come back together. So remember the first step, get everything on one side.
No matter which direction we move.
It doesn't really matter as long as you stay true to everything else. So that's a great question. If you move one thing over than the other, our sign charts will be the complete opposites, but we'll have the same answers because we'll have an opposite true statement. I'm glad Daniel's in this class. He confirms that I know that what I'm doing.
We're complete opposites. I don't know, we just are, like, smart.
You're smarter than you think.
Yeah.
I just proved you wrong.
I have a question.
What's up?
That's wrong.
What's wrong?
Why can't I just do x plus 3 and add 3 to the side? Look at my paper, guys. Do you, okay. So look, I just like added 3 because this one has is x plus 3. Why can't I just add it to the one x?
You need to make it to one fraction.
Does no one understand what I said? Instead of multiplying it by x plus 3, why couldn't I just add 3?
To the other one?
No, that's illegal. That's like a huge illegal move.
Is that one of those if you do this?
No. There's legal moves. I get what your illegal move is, and it does not work that way.
I'm getting X minus 6 in my mind.
So you're saying that if you just put a +3 down here and a 3 up there, you're good.
That's what I thought.
Okay, so let's talk about 1/2. Here's the fraction 1/2. Okay, you want to put a +3 down here and up there, and then you're good.
No.
And that'll be fine. No, it doesn't work. Then don't do it with variables.
I guess I'll start over.
Do it correctly, please. All right, shh. Let's come back together. Okay, did I do any bad math here? Daniel, does my answer match yours so far? Okay, good. I'm good.
I did it the other way.
So your signs are going to be complete opposite. That's going to be fine. So what you have to do here is combine the two fractions. You move the 1 over to one side. I just moved it over here because all the other examples have had zeros on the right side. I just want to be consistent. You could have moved it the other way, and everything you have is going to be the opposite, but your answers will end up matching up at the very end. Okay? So, like, for instance, Daniel has his on the other side, so his says a -3, but it's over here, and his 0 is over here. So he's looking for negative numbers, whereas I'm looking for positive numbers. Okay. You have to get into one fraction, which is right here. So this was all step 1. All of this was all step 1 in our steps that we did. Everything on one side and into one fraction. When we do that, the top kind of cancels out nicely. You're just going to get a 3 on top. So do I need to test any numbers on the top? No, the top will always be positive. And why are these open circles for -3 and 0? Because they're vertical asymptotes.
Wait, how is -3? Oh, never mind. I see it.
Okay, so what's the number that's left of -3 that we can test?
-4.
So -4. So on top, I'm always going to have a positive, and on the bottom, I'm going to get negative, which is it's positive. I don't pick a number between -3 and 0. So pick a -2. I'm going to get a positive on top, and then a negative positive, which is a negative. And then to the right of 0, plug in a 1, which is going to be positive over positive, which is positive. So I'm going to shade what numbers? Shading the positives, because I'm looking for numbers that are bigger than 0. Okay, any questions on this? Okay, real quick. Maybe you've noticed a pattern. Anybody notice that they keep alternating? Yeah, that's actually going to happen until what happens?
Until we
Get like a squared somewhere. When we get a squared, then weird things are going to happen. So,
are we not doing this?
I guess none of these problems have them, so.
Are we eventually like?
Are they gonna be on the quiz?
I don't know. I didn't work. Well, no, on Friday. This is not on the quiz Friday.
The quiz Friday is 2 graphs.
2 graphing questions should take you no more than 20 minutes. I'm giving you 20 minutes for giggles. It really should take you 10. Okay? And then on your quiz next week, I don't know. I didn't work that quiz next week. So just kind of be aware of it. It might be in your homework. I'm not too sure. So they typically alternate. Reason being is because they're all crosses. So even in the rational fractions, it's going to alternate unless you get it squared somewhere. Questions, comments, concerns? All right. Don't forget to like this video and subscribe below. Comment any questions you may have, and I will get back to you as soon as I can. Share this video. And any other plugs? Any other plugs here? You may want to like follow someone on Instagram. Who are we following?
Buy my merch.
All right. Well, I don't have an Instagram, so. Yeah.